what is an operator? An operator is basically a symbol. The operators in VHDL are divided into 4 categories. First one is arithmetic operators, second one is logical operators, third one is relational operators, and fourth one is shift operator. So we will see all of these one by one. What is arithmetic operators? Like some basic arithmetic operators are addition and denoted by plus sign, and subtraction, multiplication, division, and these all are basic operators we all know. And some additional arithmetic operators are exponent, absolute value, modulo, remainder, and complement. So now we'll see them. Exponent. The syntax of exponent, writing exponent in VHDL is base double asterisk radix. So like in this example, we can see like I have to write 5 raised to power 7. So 5 double star is 7. So similarly, we can write absolute value. The syntax of absolute value is ABS, and after that we can give the number for which we have to find the absolute value, like ABS of 4 equal to 4, ABS of minus 4.5 equal to 5. And the next operator is modulo operator, and it gives the remainder value. So the syntax of modulo operator is first integer, after that mod, mod, after that second integer. So like we can see in example 10 mod 6. So when we will divide with 10 with 6, so the remainder will be 4. So like 4 is written here. If 9 divided by 4, then the remainder will be 1. But here minus is written in, so we will take minus in the remainder. And next one is remainder operator. So it is same as the modulo operator. It is also used to calculate the remainder, and it is denoted by REM. 9 REM 2 equal to when we will divide 9 by 2, then the remainder will be 1. So next one is complement operator. Complement operator, it is also said not operator. It is denoted by its syntax in not, and after that we will specify boolean value like true or false in the bracket, and it will give the opposite result. Like not true, we selected not true, then it will give its result will be false. If we select not false, then its result will be true. So next one is unary plus, and its syntax is plus after that number. Like we have seen many times plus 5, plus 20. Unary means the number will be 1. Like in binary, we can see like the plus operator is between two numbers, like 1 plus 2. So it is between two numbers. That is binary plus. But in unary, it is before one number. It is like plus 5. It is telling that 5 is a plus quantity. So similarly, like unary minus, the syntax is minus sign before the number. Like minus 20. In this example, we can see that like the plus sign written in the bracket is a binary plus, but minus sign before the bracket is a unary minus. So I think it is clear. Moving on the next. These are some logical operators. Logical and its syntax is AND. Like we have to do AND between two numbers like A and B. So it will be A small, A and D, and B. Similarly, logical OR, its syntax is OR in small. Logical not op AND means NAND. Its syntax is NAND in small. And logical not op OR, its syntax is NOR in small. And logical exclusive OR, its syntax is XOR in small. Logical exclusive of not of OR means XNOR. So these all are logical operators we use in VHDL. Next one is relational operators. So in VHDL, relational operators are used to compare two operands of the same data type, and the received result always of a Boolean type. So it is used to compare two data types, and uh, the it may be a true or false. Like when we are comparing two numbers, like a equal to b, then it may be true or not true. So it may be true or false. It will be always true and false. So VHDL support the following relational operators like equal to, which is denoted by equal sign, not equal to, and less than, greater than, less than equal to, and greater than equal to. So these all are the syntax of the relational operator. So next one is shift operators. So these operators perform a bitwise shift or rotate operation on one-dimensional array of elements of bit or STD or Boolean data type. So I will repeat it again. These operators perform a bitwise shift or rotate operation on a one-dimensional array of elements of the bit uh, of bit data type, STD logic data type, or Boolean data type. So types of shift operators are SLL. It is called shift left logical. And next is SRL. It is called shift right logical. Next is SLA. It is called shift left arithmetic. And next is SRA. It is called shift right arithmetic. And next is ROL. It is called rotate left. And next one is ROR. It is called rotate right. So we will see all of these in the next slides with examples. First one is shift left logical. Like there is a its syntax is basically A SLL B. So A is shifted by left by V bits. Like A is a number or a array which we have to shift by B bits. B is the bits number of bits by which we have to shift a array. And if B is negative, then A is shifted towards right. Like if the number B is negative, then it will be the array will be shifted towards right. So we will see this thing by example. Like we have taken A vector, like we have taken this one 8-bit vector, and we perform a operation A SLL3. So the vector A is shifted by shifted left by 3 bits. Like here we can see 1 1 0 1 1, and these 3 bits are blank. So at the place of blank space we will write 0. So in the place of blank space we write 0 in SLL operators. And if we do a SLL minus 3, so it will do opposite thing. Like firstly it was going towards left, now it will shift towards right by 3 bits, and the backend places will be filled by 0. Like here we can see 0 1 1 0 1 1 1. So if we shift this thing towards the right, so it will come here, and these 3 places are vacant, so these are filled with zeros. So next is ASRL. Next is SRL, shift right logical. So ASRL B same like previous, but it is opposite to that. A is shifted right by B bits. If B is negative, then A is shifted towards left. It is similar to previous one. Like we have take the same sequence we have taken in the previous example. ASRL3. Now it will shift the sequence with towards right with 3 bits. So and so it will be shifted like 1 0 1 1 will come here, and these 3 positions are vacant, so we will fill 0 at the vacant positions. And ASRL minus 3, like it is it will shift towards left. 1 1 1 0 1 1, it will come towards, and these positions are vacant, so these are filled with 0. So we can say A SRL B equal to A SRL minus, sorry, it is, okay, sorry, it is a mistake here. It will be ASLL. Here it is ASLL. So ASLL equal to ASRL minus B, or vice versa. So we can say like, if ASL, it is SLL, ASLL and equal to ASRL minus B, or reverse, like ASRL equal to ASLL minus B. Okay, so I understand. I hope you will understand this. And next is SLA, shift left arithmetic. Its syntax is same. ASLA B. It's A shifted by B bits and filled on the right with leftmost bit. So in the previous previous two examples, we are filling the bits, backend bits with 0, but in these, in SLA or SRA, there may be a change. So if B is negative, then A is shifted towards right. So we will see this thing with example. And SRA shift right arithmetic. So A shifted by right by B bits and filled on the left with rightmost bit. And if B is negative, then A is shifted left. So we will see this by an example. Look. Now consider a sequence, like we have taken a sequence of 6 bits, 101001. So we perform an operation SLA2, means shift towards left, arithmetic shift towards left. So 1001 come here, and these two positions will be vacant. So it will be filled by if we are doing left side, then it will be filled by the rightmost bit. So here rightmost bit is rightmost bit is 1, so it will be 1 1. So rightmost bit in A is 1, so vacant place is shown in green color is filled by 1. Similarly, ASRA2, and we make a right shift to in the above, so 1010 will come here, and here two positions are vacant, so it will be filled by leftmost bit. So leftmost bit in A is 1, so vacant place is shown in green color is filled by 1. Yes, I hope you understand this. And moving towards next, ROL, rotate left. Its syntax is AROL B. This A is rotated left by B bits. Instead of filling the right B bits with a value, the B bits that were shifted off the left end are copied to the right of the shifted A bits, and array that originally, like it is an example, like if in this we just circularly shift we didn't fill any value, like we are doing previous examples, like here A B C D, and it is rotated left by 1 bit, then B will come at the position of A, and C will come at the position of B, and D will come at the position of C. So the position of D is vacant, so now A will come at the position of D, so it will become BCDA. Similarly, in this case, A is rotated by B bits. So instead of filling B bits with a value, B bits are shifted of the right end and are copied to the left of the shift A bits. Like in above example, ABCD, and it is rotated right by B bits. So it is rotated right by B bits. So C will come at the position of D, and B will come at the position of C, and A will come at the position of B. And so the position of A is vacant. Now D will come at the position of A. So it will become DABC. So now we will see this by an example. Okay, here. 1 0 1 0 0 1, it is our a vector, and if we perform a operation a rol 1, means rotate left with 1 bit. So what will happen? So if it we will rotate like all these bits, uh, like 0 will come at the place of 1, 1 will come at the place of 0, like we can see the red color. So this is the rotated vector, but this position is vacant. So what will it do? So the one at the last position, it will come here. And similarly, we perform a rol2, like so we shift this with 4 with 2 bits. So here two positions are vacant. So what will do? So the vector that so the vector the the leftmost bit come here, like 1 0 will come here. And similarly for ROL, sorry, it is also a printing mistake. It will be ROR. I will correct. I will make it. I will make this correct. It will be ROR. So if we perform a ROR 1, so it will shift towards left, so towards right, and one will the bit that will come here is 1, like 1, and similarly like a ROR 2, then these position will be vacant. So the bit at the leftmost side will come here, like 0 and 1 will come here. Okay. So here it will be an ROR. It is a printing mistake. So I will make it correct. Okay. So I hope you have understood the all the shift operators, and